All right, so here we have an interesting problem on setting entries in the matrix to 0. I guess before we get started, there was an update to the formatting of LeetCode, and like the dark mode theme doesn't apply to the entire site, and so this is just like burning my eyes. And I'm sure there's an easy way to change the settings somewhere, but I haven't found that yet, and I'm honestly not going to take the time to figure that out. But this is really awful, so I'm sorry to subject you to this, but you know, this is our lives now, I guess. Okay. But so this problem, basically we're given a matrix, and if any element is 0, we want to set the entire row and column to zeros. We have to do it in place, and so what that means is we don't want to like create a new matrix. Like, we're not going to like create a new matrix to do this. We just need to change the original matrix that's part of this function, or that's in input to this function. And so, yeah, you see examples of this. You just zero out the rows and the columns anytime there's a 0. Okay, so a straightforward solution using OMN space is probably a bad idea. So what would this solution look like? So this is sort of your basic gut reaction of like, okay, well, so in general, the issue here is that, and you can kind of see this issue by the fact that they've used different colors here for different zeros. Once you start filling in zeros, you need to somehow keep track of which zeros are being put here because I'm in the process of zeroing out the rows and the columns, and which zeros were originally here. Because if you're going through this matrix and like adding, like if you're going through this matrix and adding zeros everywhere, you might add all these zeros, and then you might see this 0 here and think naively like, oh, anytime we see a 0, we want to zero out the row and column. And so then you'll just zero this out and you'll zero everything out. So you need to keep track of what zeros were originally there so that you only zero out the rows and columns that are associated with zeros that were originally there. And you don't do any additional zeroing based on the additional zeros that you have introduced. And so one thing you could do is you could just like make a completely new matrix that keeps that's the same size and just keeps track of like where the zeros are. And so basically you could have like a new, like for this example, you could have a new 3x4 matrix that will just have like, maybe it's it'll be 1 everywhere, but then 0 here and 0 here. And then you could use that matrix to keep track of filling out the zeros, because then you could like loop over the original matrix and see like, okay, well, if there is a 0 in that other matrix that we're using to store the original zeros, if there's a 0 there, like when you're looping through this matrix, whenever you get to a row and column, you see like, okay, well, if we look in the original matrix, if there was a 0 in that row or in that column originally, then we zero it out. But otherwise we don't. So this is a way you could do it, but this uses an entirely new matrix of size, a new m by n matrix. So here, m by n. Okay, so m is the row number. Oh, I don't like that. Oh well. Yeah, because so alphabetically m comes first, so this makes sense. But like in math, typically when you're working with integers and like natural numbers, you'll start with n because like n is like the variable that you always go to for natural numbers. But then if you need a second one, you'll be like, okay, well, we have n already, so let's just add m onto it. So it'll typically be, in mathematics, you'll typically see things referred to as n by m matrices. So this has me completely flipped, but we'll be fine. Okay, going back here. Okay, a simple improvement uses m plus n space, but still not the best solution. Okay, so what does this look like? So the insight here is that whenever you see like a, okay, so let's look at this example. We have a 0 here and a 0 here. So we know that we're going to need to zero out this first row, and we're going to need to zero out the first column. Okay, let's use Python indices. We're going to have to zero out the 0th row, then we're going to have to zero out the 0th column and the 3rd column. And how do we know that? Well, we know that because there were zeros in the first row and there were zeros in, okay, fine, I'll just start at one. There were zeros in the first row and there were zeros in the first column and the 4th column. So if we think about the logic that we just used there, we didn't really care about this being like the 1-1 entry and this being the 1-4 entry. All that we cared about was there any 0 in any of the rows and any zeros in any of the columns? And then we could just use that to figure out which rows and which columns need to be zeroed out. So that's how we would use a solution using m plus n space. So you could have like one vector or one list that has m entries, which keeps track of which of the m rows have any amount of zeros. And then each of those rows will need to be completely zeroed out. And then you look at the n columns and you have another array that has n entries, and the entries here will store like which of these n columns have any zeros in them. Because if there's any zeros in them, the entire column needs to be zeroed out. And so then you can just like loop through these, you can loop through the rows that have been marked as needing to be zeroed out and loop through the columns that have been marked as needing to be zeroed out and then zero everything out that way. And so that uses m plus n space. So that's good, but it's not the best solution. And so the best solution here is basically using this idea, but if you think about it, you don't actually need to create new vectors to do this, to figure out which rows and columns need to be zeroed out. You can actually store this information in the matrix itself. So here we talked about with m, this is the number of rows. And so you would need a list that has m entries and that indicates which rows need to be zeroed out. Well, you could just store that information in the first column. And similarly, and the reason you can do that is because anytime you see I think it makes a little more sense here. Like so this entry here in the, using Python indices again, this is the 1-1 entry of this matrix. We have a 0 in the 1-1 entry. And so you can store a 0 here in the first column and here in the first row, and these indicate like, okay, well, if we have a 0 here, then this whole thing needs to be zeroed out. And if we have a 0 here, then this whole thing just needs to be zeroed out. And so basically in that way, we're using the first column and the first row. Basically, you loop through the matrix, and whenever you see a 0, you set the corresponding entry in the first row and in the first column to 0. And then once you've done that for all entries in the matrix, at the very end, you can just go through each of the columns and each of the rows, and anytime you see a 0 in any of the entries in the first row, you just zero out that entire column. And anytime you see a 0 in the first column, you zero out the corresponding row. So in this example, the way you would do that is first, you would like loop through this matrix and you would say, okay, well, there's a 0 here. So let's make this cell 0 and let's make this cell 0. And so then you would have and then you keep going through and there's no other zeros here, so that's all you would have it. So you would end up with a matrix where you have a 0 here, a 0 up here, a 0 down here. And then at the very end, what you would do is you would go through the rows, or you would go through the first row, and anytime you see a 0, you would zero out the column. So you'd go through this first row and you'd see, oh, there's a 0 here, so let's zero out this entire column, and that would give you the 0 here. And then you go through the first column, and anytime you see a 0, you zero out the corresponding row. So you would go through here and you would see, oh, there's a 0 here, and so now let's zero out the entire row, and that would set this to 0. And so at the end of the day, you end up in this situation, which is your solution. But there is one critical piece of information that you need to be keeping track of, is that this process works great if you have like a 0 in the interior here, and you can just assign it to the corresponding rows and column, or to the first row and to the first column. But if the zeros are in the first row or in the first column, then that's tricky, because that entire row or that entire column, or both in this particular example, or in this case, the entire first row or the entire first column will need to be zeroed out. But when you're zeroing it out, you can't, if you're going to zero out the entire row or the entire column, you can't use it to store the information about which other cells need to be zeroed out. So like in this example, if the example started with a 0 here, then you couldn't zero out the entire first column, because then you would later on in your code zero out every single row. So what you need to do is you need to keep track of, well, the way you can get around this is you can keep track of, like, is there a 0 in the first row, and is there a 0 in the first column? And so then you basically go through this entire process that we discussed up here. But then at the very end, once you've already filled in all the all the other zeros that aren't associated with the first row and the first column, once you've filled in all those other zeros, then you can return to the first row and the first column, and you can see, like, okay, at the very beginning of this code, we kept track of whether this row needed to be zeroed out and whether this column needed to be zeroed out. And based on what needed to be zeroed out, then you zero everything out at the end. And you can you do that at the end because you don't need that information. You're no longer using the first row and the first column to store which additional rows and columns need to be zeroed out. Okay. So yeah, and so is this a constant space solution? So the reason that this is a constant space solution is we do use additional information. We do need to store additional information in additional variables, but all we need is one variable to store if there's a 0 in the first row, and one variable to store if there's a 0 in the first column. So that's two additional variables. And the addition of these two additional variables is independent of the size of the matrix. It doesn't matter how large n and m are, you still just need those two additional variables. One to keep track of if there's any zeros in the first row, and one to keep track of if there's any zeros in the first column. And that is, contrast that with this situation where you need an entire vector of, or an entire array of m entries to keep track of the first to keep track of the first column, and an entire array of n entries to keep track of the first row. So this is not constant in space. This grows as the size of the matrix grows. But the solution that we discussed of having zeros in the first row and the first column is independent of space. And so that's going to be the most efficient solution. I mean, is that provably the most efficient solution? I would assume not. But oh well, doesn't matter. I don't know how. I feel like it would be tricky to prove that there is no more efficient solution, but at the very least, it's constant in space. So it's a really good solution. Okay, so I'm going to write out what this code is going to look like because writing helps me learn. Okay, and then we're going to code it out. Okay, so here we're going to start with our variables. So n is, okay, so m. Okay, well this is, okay, so I'm very likely to make an error here because I have n and m flipped because I was doing it the mathematician way. But I'll do it the way that we need to do it and hope that I am consistent. So m is going to be the length of the matrix. Why is this? Because the matrix, as you can see here with the way that matrices are represented in Python, it's a list of lists. And the outermost list has one entry for each row. And each of the entries is the elements of that row. And so the number of elements in the outer array is the number of columns. Okay, I may have misspoke there, but the number of entries in the outside array is the number of columns, because we see here we have one array, we have another array, and we have a third array. So those represent the 3 rows. And then within them, these represents the actual values in that row. And so the number of columns will be the number of entries here. Okay, so m we want to be the number of columns. No, m we want to be the number of rows, and so it's just the length of this list matrix, because that's the number of lists. Each of those lists represent a row, so the number of rows is just the length of matrix. And then n, the number of columns, is just the length of any entry of the list matrix. So any entry here, the length of any entry is going to be the number of columns. And so for here, we can just choose the first one, or the 0th one. Okay, so now, like I said, we need to keep track of if there are zeros in the first row or column. So we'll do 0 in first row. This is going to be any. So this will be true if any of the statements inside here are true. So it's like a huge OR statement. So for 0 in the first row, we need, well, 0. Well, you look at the first row and you check for any zeros. So and the first row is going to be all of the entries in the first list within matrix. So it's going to be any matrix 0j, because it's row 0, column j. And this is, I'll continue here, 4j. This is not great spacing and stuff, but it's, I'm handwriting things, so we're going to make it work. So for j in range n, because n is the number of columns. I'm actually going to write this here. Clause, no. Just so that I don't forget. So j in range of n, because that's the number of columns. Okay, and then likewise, 0 in first column. Let's do that. It's going to be any. This will be similar matrix, but here I 0. The ith, because this will be the ith row and the 0th column. This is for I in range, the number of columns, which is m. Okay, cool. All right, and now what we want to do is we want to go through the matrix, and anytime we see a 0, we want to store a 0 in the first row in the first column to indicate that we will need to zero out the corresponding row and column. Okay, so for I in range, and we're going to go from 1 through m, because we've already figured out any zeroing that needs to be done in the first row and the 0th row and the 0th column. So now we just need to look at everything else. For j in range 1n. Okay, so we're basically looping through all of the entries which are not the first row or the first column. Okay, so if this ij entry in the matrix, row I, column j, if this is equal to 0, then we need to set the corresponding value in the 0th row and the 0th column to 0. So matrix 0, j equals 0, that's the 0th row, and matrix I 0 equals 0. Then that's the corresponding value in the 0th column. Yeah, cool. All right, so now once we've done that, once we've done this, now the first row and the first column store all the information about which additional values, or which additional rows and columns need to be fully zeroed out. And so basically we just loop through this entire, like everything except for the first row and the first column. We loop through everything again, and if there is a 0 in the first row, or if there is a 0 in that, I keep mixing up the indices. I'm going to try to keep calling it the 0th row. But if there is a 0 in the 0th row or 0th column, then we need to set that entry to 0. So for I in range, this is going to start out exactly the same. 1m. And unfortunately, we can't combine these two loops, because we need to have all of the information, all of the zeros stored in the first column and first row first before doing this. And I did it again. I called it the first one. I should call it the 0. Oh well. If the entry in the 0th, so here we're going to loop through the rows and columns, and for the ij entry in the matrix, if the entry in the 0th row is 0, or in the 0th column is 0, then I guess we don't need this. I don't know. This indentation really doesn't need to be there. Well, writing code by hand is weird, but it can help you learn. So then we set this to 0. I do wonder if it would be more efficient to like loop through the 0th row and then say like, okay, well, loop through the 0th row, and if you come across a 0, then loop through the columns and zero out the column. I think that might be more efficient. And then you would do the same thing. You would loop through the 0th column, and anytime you see a 0, then you loop through the row and zero out the row. And that way you only have to like zero out the rows and the columns that need to be zeroed out, rather than having to loop through the entire thing. But that would also be writing more code. And honestly, I'm just not going to do that. Okay, so now everything except for the first row and the first column is fine. Everything has been zeroed out perfectly. The only thing we need to do now is figure out if we need to go back and zero out the first row and the first column. And that's something that we indicated early on. So if 0 in first row, then we have to zero out the first row. For j in range m, the number of columns, matrix 0 j equals 0. And then likewise, so if 0 in first call, we loop through the rows, or the row indices, and zero them out. Okay, and then we return absolutely nothing because we are editing this in place. Okay. All right, cool. So that's what the code looks like. And we've explained sort of how we go through it. So now let's just type it up. So m equals lane matrix. Let me make sure that I did not immediately mess this up. Nope, I am good. Okay. N equals lane matrix 0, not 9. Okay. 0 in first row is any matrix 0j equals 0, 4j in range. What is this? I wrote down m, so this should be n, right? Because this is going through the columns, and there are n columns. Okay. 0 in first call is any matrix I. 0 equals 0 for I in range m, which is the number of rows. Okay, cool. So now we do the loop, or one of the loops, for I in range 1 through n, for j in range 1 through m. Okay, I number of rows, j. Did I mess this up? I did. I loops through the row indices, which is m. J loops through the column indices, which is n. If matrix I, j equals 0, then we need to store the information in the first, or the 0th, this is the 0th row, and then the 0th column. We need to store the information that these need to be zeroed out. And then we actually do the zeroing out. 1m if matrix 0j equals 0, or matrix I 0 equals 0, then matrix ij equals 0. Okay, now that we've zeroed out all the rows and columns outside of the first row, outside of the 0th row and the 0th column, now we need to zero out the 0th row and 0th column if necessary. So if 0 in first row for j in range m, that is not right, I'm pretty sure. If 0 in the first row, we need to loop through the columns, which are indexed by n. J in range n, matrix 0th row, jth column is 0. And we just zeroed out the first row. If 0 in first column, then for I in range m, so the row matrix I 0 is 0. That's zeroing out the zeroing out the 0th column. And that's our code. And so we run it, and I made a mistake. Oh, I mistyped. All right, cool. Yeah, so that solves it. So yeah, it took it's a bit tricky. You have to come up with this idea of actually storing the information in the matrix itself. But then once you know that trick, then you just implement it. But yeah, this is more of an interesting problem. There's more you have to think about here. But yeah, this is a solution and it works. So there you go.